So we're on topic 8, page 36, and the title is Graphing Linear Inequalities. And we're going to, on page 36, we're going to divide it into three parts. First of all, we're going to define linear inequality. Then we're going to see the procedure for graphing a linear inequality. And then finally, we're going to look at the example of a graph of a linear inequality. So first of all, let's go to the definition. And linear inequality involves two variables. So we have the y and the x variables. A is the coefficient of x, and a and b are elements of real numbers, so they appear on the real number, and a and y cannot both be 0. Now let's go back a little bit, and a linear equation might be y equals 2x plus 1. If an example of a linear inequality would be, instead of having the equal sign, we might have the greater than sign. We could have the greater than or equal to sign. This means greater than or equal to. This means less than. This means less than or equal to. So over here, we are not just limited to the greater one. We can have less than, greater than or equal to, or less than or equal to. But here we have just the equal sign in a straight linear equation. The moment we replace this equal sign with greater than, less than, greater than or equal to, less than or equal to, it's no longer a linear equation. We call it a linear inequality. So that's the basis for this definition. Now, how do we graph a linear inequality? First of all, we graph the boundary line of the inequality, which is the line usually made up from the equation, and I'm going to show you that. And we're going to see that it's dashed if it's not included. I'll explain what I mean. We're going to shade the region that represents all the points, ordered pairs that satisfy the inequality. So we're going to use a test point off the boundary line to check the value of the original inequality. So the first thing we do is we're going to have to graph the boundary line, which we've done before, and we do that similar to in the same way that we do it for a linear equation. So the boundary line for a linear equation and a linear inequality are obtained in the same way. We can do this either by calculating the x and y intercepts and then joining these points. So we calculate the x-intercept by setting y to 0 and the y-intercept by setting x to 0, and then joining these points. The other way that we could use is use the actual equation we're given and find two ordered pairs that fit on the line. So we can do it by either one of these, and we're going to do it that way. Supposing we have the equation y is less than 3x. First of all, we set y equal to 3x. And if you set x to 0, then y is 0. So if x is 0, y is 0. So 0, 0 becomes an ordered pair that fits on the line. If we set y to 0 right over here, then x is 0. So we can only get an ordered pair from this method. We've only got one ordered pair that fits on the line, but we need 2 points, 2 ordered pairs, in order to draw a straight line. So what we do is, to find another point, we arbitrarily set x to a value and calculate y. So if I set x equal to 1 in this equation here, x equal to 1, then y equals 3. and the second ordered pair becomes 1, 3. Now we can join the points 0, 0, and 1, 3 to obtain the line. So, for example, here's the point 0, 0, and here's the point 1, 3, and this is the boundary line. Now, the reason that it's dotted, if we go back up, we have the line dashed if it's not included, or I may refer to it as dotted, because we're talking about y less than 3x. So since there's no equal sign here, no equal sign in this, we're going to make it a dotted or dashed line here. So we connect this point 0, 0, one of the ordered pairs that we found, with 1, 3, which was the second ordered pair that we found when we made x equal to 1 and y equals 3. Determine now what side of the line to shade. Choose a point that lies on one side of the line. So we could choose, for example, 1, 0 lies right here, roughly speaking, and minus 1, 0 lies here. Because we're going to shade on one side of the line because of the inequality. So we're going to try 1, 0 here, this a point that lies approximately here. I mean, x is 1, y is 0. And we're going to substitute it into the inequality. So we're going to substitute x is 1 and y is 0. Y is 0, x is 1. Is 0 less than 3 times 1? In other words, is 0 less than 3? The answer is yes. So we are going to shade on this side of the line, because that test point is going to shade on this side of the line here, because the test point worked with the inequality. Let's say I choose minus 1, 0, which lies on this side of the line. Minus 1, 0 would be roughly around here or around here. So I'm going to put it into the equation and then ask, into the equation y less than 3x, I'm going to ask that, is 0 less than 3 times minus 1? And 0 is not less than minus 3. This 3 times minus 1 is minus 3. 0 is greater than minus 3. So we're not going to shade with the point minus 1, 0 in the equality. So now we shade on this side of the line and we redraw the line. And you can see what we did is we checked the point 1, 0 here, and the inequality was true. When we checked with a point on this side of the line, the inequality was false. This 0, 0 refers to this point right here at the origin, by the way. So let's go over this again. We graph the boundary line, and we do that by either of two methods. We can either use the x and y intercept method, or we can use it with a set of test points. So in our case, we found that there were the two ordered pairs were 0, 0, and the other one was 1, 3. So we got 0, 0, 1, 3. Those, now we drew the line. And the reason we drew this dotted, because there was no equal sign included right here. No equal sign. So if there were an equal sign, we would make it a solid line, a line with no dots on it. Okay, so because it has less than, we do not include the boundary line itself. Once we got that, we checked it with 2 points. One, you can check it with just 1 point, and we found that it worked with a point on this side of the line. So we chose the point 1, 0. The equation was true right here, so we have to shade with that point being on this side of the boundary. If we choose a point on this side of the boundary, the inequality y less than 3x will not work. Now, third part of page 36 is to take this inequality and draw a graph for it. So the first thing we always do is draw a boundary line, and that's the line where on one side of the inequality we're going to shade, and the other side will not have any shading. We have to decide which side of the boundary line we're going to shade. So as I said, one way to get the boundary line is by the method of intercepts. For the y-intercept, we set x equal to 0. So if we set x equal to 0, and we always deal with the original equation, we just forget about the inequality for the time being. We just put an equal sign here to get the boundary line here. So we set x equal to 0, y equals 4. 2 times 0 is 0, y equals 4. So we know here's the point, 0, 4. X is 0, y is 4. So x is 0, y is 4, so we have one intercept as being 0, 4 right here. Then we can get the x-intercept, and we do that by setting y equal to 0. We set y equal to 0, and we put it back into the original equation. 0 equals 2x plus 4 right here. 0 equals 2x plus 4. Bring the 4 from the right to the left. 2x equals minus 4. X equals minus 2. So minus 2 comma 0 is another intercept. That's this intercept here. So we found the y-intercept. Remember, the y-intercept is where the graph crosses the y-axis, and at this point x is 0. This is an x-intercept, and where this crosses the x-axis, y is equal to 0. Now we connect these 2 points. And because there's an equal sign right up here, this line is drawn without any dotting or any shading. So it's just drawn as a solid line right here. Okay, so now we're going to check with a test point. And 0, 0 is the easiest one to check with because usually the arithmetic is the least difficult here. So we're going to check with this point 0, 0 in here and plug it back into the original equation. So y is 0. Is 0 less than or equal to 2x, where x is 0, plus 4? Is 0 less than or equal to 4? The answer is true. So we're going to shade on the side of the line which contains a point that fits the inequality. In this case, it's 0, 0. We don't have to choose 0, 0. We could have chosen, for example, 2, 0 right over here. X is 2, y is 0. And we could have chosen a point up here. We could choose any point that we want, but we can clearly see if this is the line, the boundary line, we can see that the origin definitely falls on one side of the line. So the operations with 0, 0 are the easiest. Now, just to check the choice of the shaded region, supposing I wanted to try a point that I know lies on this side of the line, right here. I know, for example, minus 4 comma 0, which is over here, roughly speaking, lies on this side of the line and shouldn't work. It shouldn't fit the inequality because 0, 0 worked, and that's on this side of the line. So I want to try a point that's on the other side of the line. Let's just check it. So I try 4, 0 and plug it into y less than or equal to 2x plus 4. And I ask the question, is 0, because y is 0, here, y is 0, less than or equal to 2 times minus 4 plus 4. Now, 2 times minus 4 is minus 8, plus 4 is minus 4. Is 0 less than or equal to minus 4? And the answer is no. 0 is greater than minus 4. So as a result, we know that minus 4, 0 cannot fall within the shaded region. So let's go over this again, what we did in this problem. We're given the inequality. We have to set up the boundary line first. And we did this by setting x equal to 0 and finding y equal to 4. So we got this point over here. Then we set y equal to 0 and found x was minus 2. So we have this point right here. We connect these 2 points. We connect them, and that gives us our boundary line. Now we have to know, do we shade on this side of the line, or do we shade on that side, this side of the line? We're going to test the point 0, use that as a test point. We don't have to, but as I said, the real makes it easier when everything's 0 to do the calculation. And we find when we use 0, 0, and put it back into the equation, this equation right here, the equality holds true. 0 is less than or equal to 4. It's true. So I'm going to shade that side of the line which has this point in it. Finally, I checked with another point to verify that lies on the other side, and I'm predicting that it shouldn't work. And what I found was when I plugged it back into this original equation, it didn't work. So that I can't use that line, that point cannot fall within the shaded region.